Now let's talk about expectation. Expectation is often what's used in gambling games. But remember that expected value is the same thing as the mean. Expectation is just another word that means expected value or mean. Let's work a few problems together. 1,000 raffle tickets are sold at $1 each for 4 prizes of $100, $50, $25, and $10. After each prize drawing, the winning ticket is then returned to the pool of tickets. What is the expected value if you purchase 2 tickets? Let's begin by setting up a table. Since we have 1,000 raffle tickets, they're sold at $1 each, and we're returning the winning ticket to the pool. This means we're doing something with replacement. So in our probabilities, our denominators are going to all be the same. Let's determine what x should be. We get a prize of $100, but how much do we spend? So this is something to keep into consideration when we're doing problems with expectation. We want to make sure that we're taking into account how much it costs to play the game, because that associated cost affects our outcome. How much money do we actually win? So for the x, we're looking at the net amount of money that someone would get if they win a prize. So we buy 2 tickets. That means we're down $2. If we win the $100 prize, minus our $2 that we paid for the ticket, we've earned $98. Similarly, for $50, if we win $50 but we still bought 2 tickets, we really won $48. For $25, we really earned $23, minus the $2 for the 2 tickets. And then for the $10, we really earned $8. Now I have one more blank in my x's. Do you know why? Are these all the possible situations that can come out of a drawing for a raffle? I win $100, I win $50, I win $25, I win $10, or I don't win anything. So if I don't win anything, what does that mean that I've gained or lost? I've lost $2. I won nothing. All right, so now let's talk about our chances of winning. It says we purchased 2 tickets. So out of the 1,000 tickets, we have 2 chances of being drawn for a prize. For any prize. We have 2 chances of being drawn. Out of how many total? 1,000. What's the probability we don't get drawn at all? Remember that one of the properties of a probability distribution is that all of the probabilities have to add up to 1. The way I get this to add up to 1 is I take 1 minus what I already have there. So I have 2, 4, 6, 8 out of 1,000 for the 4 different prizes that I could win. So my probability of losing will be 1 minus that. 1 minus 8, 992 out of 1,000. And now that we've just created our probability distribution, we can try to answer this question. What is the expected value if we purchase 2 tickets? So the purchasing 2 tickets comes in the probability. That part's taken care of. Now we need to find the expected value, which, remember, expected value is just the mean, which means we sum x times p of x. So we'll take 98 times 2 out of 1,000 plus 48 times 2 out of 1,000 plus 23 times 2 1,000ths plus 8 times 2 1,000ths. And then the last one, minus 2 times 992 out of 1,000. This is all fine and dandy, but I'll be honest with you, I don't like punching in all of those numbers. Let's use technology. To get the technology to work for us, I don't want to put 2 divided by 1,000 in that box. My technology is not recognizing this as a number right now. I need to tell it to do the division. And see, even right now it looks like a date, like February in the year 1000. Ooh, terrible. So we tell it to calculate the division. Equals 2 divided by 1,000. And it's doing something funky because it auto-formatted my cell to be a date. Okay, so we need to fix this. Let's try this again. It's going to give me nonsense. If this happens, it's a format issue. So I'm kind of glad this happened for us. Come up to format, up to number, and we'll change it to number. And it looks weird again, so let's do equals 2 out of 1,000. And I think I just need to increase the decimal, and I do. Yep, I just needed to increase the decimal on that one. Okay, let's keep going. Equals 2 1,000ths equals 2 divided by 1,000. Forgot the division. There we go. And then the last one equals 992 divided by 1,000. Or, if you don't trust yourself on that calculation, you can also get the technology to do it. 1 minus sum, add those guys up. And so just showing again, 1 minus the sum of all the other probabilities should equal the probability in my last spot. Now to do x times p of x, I'll make one calculation and drag it over, and then we'll add it up. And we get negative 1.63. So on average, we are losing $1.63. So if we were to play this raffle game over and over again and keep track of our winnings each time, or losings, average all of those up, again, over a very long period of time, we would lose every game, on average, $1.63. Let's take a look at the next problem. A landscape contractor bids on jobs where he can make $3,000 profit. The probabilities of getting 1, 2, 3, or 4 jobs per month are shown. Find the contractor's expected profit per month. So we can play a very similar game that we just did. Find our expected value, or the mean, sum of x times p of x. So we'll multiply 1 times 0.2 plus 2 times 0.3 plus 3 times 0.4 plus 4 times 0.1. And we could do this in our calculators. There's nothing wrong with that at all. If we add them up, we get 2.4. Now, go back to your problem. You're being asked to find the contractor's expected profit per month. What does X represent in this problem? X represents number of jobs, right? So this 2.4 is jobs. He can expect 2.4 jobs per month. Well, how do we turn this into profit? If he can expect 2.4 jobs on average, we just need to take the number of jobs and multiply by his profit, $3,000. And if we multiply that out, 2.4 times 3,000, we get $7,200 for his expected profit.